The Aurora Borealis, also known as the Northern Lights, is a natural light display in the Earth's sky, predominantly seen in high-latitude regions around the Arctic. It occurs when charged particles from the Sun, carried by the solar wind, enter the Earth's upper atmosphere and collide with gases such as oxygen and nitrogen. These collisions excite the gas particles, causing them to release photons of light in various colors. The most common auroral colors are pale green and pink, produced by oxygen molecules. Nitrogen molecules can also produce purple, blue, and reddish colors in the aurora. The auroras form complex patterns and shapes that can appear as curtains, arcs, coronas, rays, or other formations that can undulate and change rapidly. They are typically concentrated in oval rings around the Earth's geomagnetic poles. The intensity and patterns of the Aurora Borealis are influenced by the level of solar activity and the orientation of the Earth's magnetic field. During periods of high solar activity, with more charged particles streaming from the Sun, the auroras can be brighter and extend further from the poles. Watching the ethereal and dynamic displays of the Aurora Borealis is a popular attraction in Arctic regions like Alaska, Canada, Greenland, Iceland, northern Scandinavia, and Siberia. The auroras are caused by the interaction of charged particles from the solar wind with the Earth's magnetosphere. The solar wind is a stream of plasma, charged particles, constantly being ejected by the Sun. When this solar plasma interacts with the Earth's magnetic field, some of the particles get funneled down along the magnetic field lines towards the polar regions. The specific colors of the aurora depend on which atmospheric gases are being energized and the level at which they are excited. The most common auroral color is a pale green, produced by oxygen atoms at heights of 100 to 300 kilometers. Reds can occur from oxygen atoms at lower heights below 100 kilometers. Nitrogen molecules create blue, purple, and reddish colors. The auroral displays can change rapidly, with curtains, arcs, and rays constantly moving and undulating. This is due to the constantly shifting patterns of the solar wind and the Earth's magnetic field shaping where the charged particles precipitate. Auroras occur on other planets with magnetic fields and atmospheres like Jupiter, Saturn, Uranus, and Neptune. Jupiter has the most spectacular auroras in our solar system. Studying the aurora has helped scientists understand the composition of the upper atmosphere as well as the interactions between the solar wind and planetary magnetic fields. For the best views, head to higher latitudes in an oval around the magnetic poles between 65 to 72 degrees latitude on dark, clear nights. Peak times are typically around the equinoxes in March/April and September/October. In very remote areas, the auroras can produce subtle crackling, whizzing, or hissing sounds due to the interaction of the charged particles with the Earth's magnetic field. The name Aurora Borealis comes from the Latin words for northern dawn. It was given this name by Galileo Galilei in 1619 due to the aurora's resemblance to the morning twilight in the northern sky. The auroral displays typically occur between 90 to 150 miles, 145 to 240 kilometers, above the Earth's surface, in a region called the ionosphere. This is where the charged particles from the solar wind interact with the gases in the upper atmosphere. The auroras form an oval-shaped region around each of the Earth's magnetic poles. These ovals expand and contract based on solar activity levels. Auroral activity rises and falls in cycles roughly matching the 11-year solar cycle of the Sun's magnetic activity and sunspot levels. In the southern hemisphere, the auroras are known as the Aurora Australis or Southern Lights. They are the same phenomenon, just mirrored around the opposite magnetic pole. Many northern indigenous cultures had rich folklore about the auroras, interpreting their dancing lights as spirits or omens. In the 20th century, advances allowed detailed study of the auroral physics through satellites, ground instruments, and spacecraft sending instruments through auroral displays. The crackling, whizzing sounds sometimes heard during auroral events are likely caused by the flow of electrical currents along the magnetic field lines. The auroras often occur in periods of increased activity, called auroral substorms, caused by injections of charged particles from the magnetosphere. These can last between 30 minutes to a couple hours. Some of the most iconic auroral forms are the arcs and curtain-like rays that extend east-west, caused by strong upward currents following magnetic field lines.